Hi everyone. So our job today is to learn how to find the greatest common factor, and we call that GCF for short. So the greatest common factor of two numbers, or three for that matter, and so on, is the largest number, or the largest factor, that will divide evenly into all of the numbers that you're trying to work with. In most cases, we're going to be working with two numbers, and our examples today will be with two numbers. This is a useful skill in problem solving. We'll be practicing some problems with this idea. So this is just a little picture here of what the greatest common factor is. So you can see here that there's a list of the factors of 12, and then there's a list of the factors of 16, and they've circled all of the common factors, or the same numbers in each of these strings that would be able to be used to multiply to get these numbers that we're looking at. And then they've circled the largest one. So the greatest common factor is the largest factor that you find in both of the numbers that you're looking at. So of course, let's look at some examples. So to find the greatest common factor of our two numbers, we're going to use something called the ladder method. Now the ladder method really is just kind of an easy way to do prime factorization. So when you hear the word prime factorization, this is an alternate method to do that. All right, so our job is to find the greatest common factor of the following numbers. So we've got the numbers 36 and 54. So my first step is that I'm just going to write these two numbers down next to each other. And then I'm going to start making my ladder. I'm going to make the first rung of my ladder. You know how ladders have steps? Those are called rungs, R-U-N-G, rungs. And so there's my first rung. And I'm going to figure out which is the smallest prime number that will divide into both of these numbers. And so I know that my smallest prime numbers are 2 and 3. And those are very useful for this skill here. So I see that both of these are even, so obviously they can be divided by 2. Well, 2 divides into 36 18 times, and 2 divides into 54 27 times. Now I'm going to make another rung of my ladder so you can see it looks like some steps that I could climb. That's where my ladder comes from. And I'm going to decide what small prime number would divide into both of these. And so I know that 3 divides into both of those. So 3 divides into 18 6 times, and 3 divides into 27 9 times. Well, I can still divide these numbers out by a common factor, and so I'm going to do that. And I know that 3 is the prime number that would divide into both of those numbers. So 3 divides into 6 2 times, and 3 divides into 9 3 times. Now I'm done. I don't have any more common factors that I can divide out of these two numbers. So to find the greatest common factor, I'm going to take these numbers along the side. There might be 1, there might be 2, there might be 3, there might be 5. And I'm going to multiply them together. And so I am going to take 2 times 3 times 3, and that will be my greatest common factor for both of these numbers. It'll be the largest number that would divide evenly into both 36 and 54. And so I'm going to do that multiplication. 2 times 3 is 6, and then 6 times 3 is 18. So 18 is the greatest common factor of 36 and 54. It's the biggest number that will divide evenly into both 36 and 54. All right, let's look at a couple more examples. Okay, so here's 40 and 24. So again, we're going to write the two numbers next to each other, 40, 24, and then we're going to start making our ladder. We're going to divide both of these by 2 because they're both even numbers. So 2 divides into 40 20 times, 2 divides into 24 12 times. And then I see that I can do that again, divide both of those by 2. There's the second rung of my ladder. 2 divides into 20 10 times, 2 divides into 12 6 times. Again, can divide both of those by 2. There's rung number 3. 2 divides into 10 5 times, 2 divides into 6 3 times. At this point I'm done because I don't have any other common factors. There's nothing else besides 1 that I can divide into 5 and 3. And so I'm going to look at the numbers along the side, and I see that it's 2 times 2 times 2. So my greatest common factor is 2 times 2 times 2. That'll be my GCF. So 2 times 2 is 4, and then 4 times 2 is 8. So my GCF here is 8. The greatest common factor, the biggest number that will divide into both 40 and 24, is 8. All right, one more example here then, and then we'll look at some steps and a problem-solving situation. So I've got 65 and 120, and I want to find the greatest common factor. Again, list my two numbers, 65, 120. Look for the smallest prime number that will go into those. And so I'm looking at those, and I see that those are both divisible by 5 because they end in 5 and 0. And so 65 divided by 5 gives me 13. And then 120 divided by 5 goes into 12 2 times. That would leave 20 left over. 5 goes into 24 times. And so I see that I have no common factors left here. And so I'm done because there aren't any common factors. Even though this isn't a prime number yet, there are no common factors. And so the greatest common factor for 65 and 120 is 5. I don't even have to do any multiplication there to figure that one out. And so my greatest common factor is 5. All right, well, let's just kind of sum this up with some notes. We're going to, the steps for this process is to write the two numbers next to each other, and then draw one rung, remember those are called rungs, of the ladder under both numbers. And then we're going to find the smallest prime number that will divide evenly into both numbers. We're going to keep adding ladder rungs and dividing until the numbers don't have any more common factors. In other words, we can't divide anymore because there isn't anything common to them, any factor common to them. Then we're going to multiply the numbers along the side of the ladder. And probably, to me, this would be the easiest thing that you might confuse is which numbers do you multiply together. So just remember that it's the side of the ladder for the greatest common factor. Okay? So finding the greatest common factor can be useful in problem solving. Here's a problem for us to solve. You are making treat bags for a party. You have 24 Smarties and 36 chocolate bars. What is the greatest number of treat bags you can make? And so we're looking for the biggest number that will divide evenly into both of these numbers so that we know how many treat bags we'll be able to make. And so we're going to use our process here, 24 and 36. There's my first rung. They're both even, so I'll divide by 2. 2 divides into 24 12 times. 2 divides into 36 18 times. They're still both even numbers, so I'll divide by 2 on my next rung. 2 divides into 12 6 times. 2 divides into 18 9 times. Now they're not both even, but they can both be divided by 3. So 3 divides into 6 2 times. 3 divides into 3 divides into 6 2 times, and 3 divides into 9 3 times. Thought I said that wrong. Okay, so I'm done because these two numbers are relatively prime. In fact, they're both prime numbers. I can't divide them evenly by any other number besides 1. And so I know then the numbers on the side are the numbers that I want for greatest common factor. Could maybe make a G out of that. Go around like that. All right, and so we want that 2 times 2 times 3 is going to be our greatest common factor for 24 and 36. So 2 times 2 is 4, and then 4 times 3 is 12. We could make a total of 12 treat bags. Now if you wanted to figure out how many Smarties you had in each bag, you would just take 24 divided by 12, so you'd get 2 Smarties in each bag. And you'd take 36 and divide that by 12, and so you'd get 3 chocolate bars in each bag. That sounds like the way to go for me because I'd rather have the chocolate than the Smarties. All right, guys, we'll practice with this a little more in class. I'll see you then. Bye.